Hi everyone. In this video, we are going to discuss this example of Laurent series. We have this function and we have to find its Laurent series for 4 different domains, right? So Laurent series, that means we try to express this function as a power series. We try to find its power series which will be convergent in given 4 domains, right? So for each domain, we will have the different series. So let us write the given function first. What we have what is the function we have? F of z is equal to 1 upon z into z minus 1. So what is our first task? Whatever the function we have, if you have denominator, we will find its factors. Fortunately, they have expressed as a product of two brackets or two functions, you can say z and z minus 1. We will try to make them separate, so it will be easy to find its power series. So now the question is how to make them separate. So we have one beautiful method, that is partial fraction. So let us use to make them separate. In partial fraction, what we do, we consider a upon the first bracket, that means here we have a term only z plus b upon second bracket or the second term z minus 1. Okay, so I am trying to make them separate, right? So that's why I have considered this one. So let me write assume. So in this way we have assumed. So now simply we have to find the values of a and b. After getting values of a and b, we can easily write separately. Okay. So to find the values of a and b, what will I do? I will cross multiply. So if you cross multiply, what will you have? A into z minus 1 plus b into z divided by the product of denominators. Okay. See, let us compare. These two are equal, having same denominators. So we can cancel denominators and simply we can equate numerators. So 1 is equal to a z minus 1 plus bz. Still you remember na, our target is to find the values of a and b. So for that I am trying to bring zeros here. See, what will I do? I will simply put z is equal to 0. If I put 0, let us see what will happen. 1, here I am putting 0. So a 0 minus 1 and 0 into anything? 0. So 1 is equal to minus a and a is equal to minus 1. So in this way I got the value of a. So here you can put anything, but we should get some value of constant. Getting? So we always try to bring zeros. So it will be very easy task then. So let us see. See, I got the value of a, but still I want the value of b. So I want the value of b, so that's why what will I do? I will try to bring 0 here. So for that I need to put z is equal to 1. So 1 minus 1 will be 0. So let us do that. I am putting z is equal to 1. Left hand side is 1. If I put 1 here, 1 minus 1, 0. So 0 into anything 0 plus I am putting 1 here. So b into 1. So b is equal to 1. So in this way I got the values of a and b. So let me write here, therefore f of z is equal to what is our a? A is minus 1. So minus 1 by z plus what is our b? B is 1. So 1 upon z minus 1. So in this way we have made them separate. Okay. So after that we will consider those regions one by one and we will find Laurent's expansion of a given function. Okay. Just make a screenshot of it, then I will go further. So now let us consider those regions one by one. Okay. I am going to consider those regions. But before that, I need to tell you very important thing. That is, see, if you have any example of Laurent series, mostly we use two series only to find the Laurent's expansion. So let us recall it. So 1 upon 1 plus z and 1 upon 1 minus z, these are two series. Okay. So what is series of 1 upon 1 plus z? 1 minus z plus z square minus z cube plus z is to 4 and so on. But see, this series is valid for mod z less than 1. That means if this condition is true, then only we can expand in this way. Getting? So similarly, we have series for this one also, 1 plus z square plus z cube and so on. The condition is again mod z less than 1. If the condition is true or it is possible, then only we can expand it in this way. So there is very small difference and we can easily keep in our mind. When we have 1 plus z, we have alternating minus plus signs, but when we have minus signs, we have all plus signs. So these are main series, and using them we easily find Laurent's expansion of any function. Okay, so this right now we have this function. So let us consider the first region. So let me write first for 0 less than mod z less than 1. So before starting the solution, let us try to understand some geometry of it. See, what will I do? I will replace inequality by equality. So what will you have? Mod z is equal to 1. So we know that this is equation of what? This is a circle, right? And what is its center? Its center is 0, 0. And what is its radius? Its radius is 1. Since the standard equation of circle is mod z minus z naught is equal to r, this is center and this is radius. Okay, so here you can easily see we have a circle. Let me show here. So this is real axis and this one is imaginary axis. We have a circle with center 0, 0 origin and radius is 1. So I can draw a circle like this. I can draw a circle like this. See, I'm drawing a dotted lines here because, can you guess? Because here we have strictly less than. Okay, strictly less than. That means we have to consider a region which, that means we have to consider this open disk. And see, mod z is strictly greater than 0. That means that origin is removed from that. So such disk we have. So this is the region of convergence. For this disk, we have to find a Laurent series. Okay, so let us go further. Okay, so the geometry is over. Let us consider the region now. See, this thing we have. So let me mention. We have. I'm writing the very important thing, that is mod z less than 1. You remember we have seen it somewhere. Yes, it is a condition, right? It is a condition of these two series. So they have directly given to us, so we can easily find the expansion. So let me consider the function f of z. What is the function we have? Minus 1 by z plus 1 upon z minus 1. So what will I do? I will try to bring the term which we have got inside a mod. Inside mod what we have? Z. So if I get z in denominator or in numerator, I will stop there. So z we have here. So I will not disturb this term. I will keep as it is, since whatever inside mod I have already given. It is already given to us. But see, mod z is there and here we have z minus 1. That means we need to expand it. Let us see how to expand. Minus 1 by z. The condition is already satisfied. That means definitely we can use those series directly. But see, one problem is there. Here you can easily see for this series we have 1 first. And what we have? Z first. Actually, we want 1 first, then only we can expand. So how to bring 1 here? I will take minus sign common. So this sign will get changed. Minus sign common, so it will be plus and this will be minus, right? Yes, if you take minus sign common. See, this is equal to minus 1 by z minus is already there, right? 1 upon 1 minus z, same thing we have. And the condition is also satisfied. So that's why definitely I can use this expansion and I can write 1 plus z square plus z cube and so on. See, this way I got the Laurent series. That's it. It is over. So the first task is over. That means we have considered the case 0 less than mod z less than 1. And this is the region of convergence which they have already given to us, right? Okay, so I got the Laurent series for the first region. So let us go for the second, just make a screenshot of it, then I will go further. Okay, so I am discussing a second region now. The second region is 1 less than mod z. So let us discuss geometry first. Okay, so I will replace inequality by equality, so we can easily draw the diagram. So we will have mod z is equal to 1 if you replace inequality by equality. Again we have got a same circle. Let me show here. Same circle. Get it? Real axis, imaginary axis, center 0, 0, radius 1. But the problem is that here we have mod z greater than 1. That means we have to consider the exterior part of that circle. So we have to consider this part of circle, and this is the region of convergence. Getting? See, actually, let me tell you one thing. It is not necessary to draw a diagram each time. But see, we should know now what we are doing. So that's why I am drawing the diagram. If you do not write the diagram, then also our answer will be correct. So let me remove this one. Okay. So this is the region we have. So this is a very important condition we have. So let us start with it. So we have 1 less than mod z. Our ultimate aim is to use those series and expand the function for the given region. Getting? Did you notice one thing? In this series, the condition is mod z less than 1. And what we have got? 1 less than mod z. Something is wrong. We want something less than 1. That means in the right hand side, we want 1 and we got mod z. What will I do? I will divide both sides by mod z. Let us see what will happen. If we divide by mod z, we will have 1 by z here. That mod z will come on this side. And if you divide by mod z, we will have 1. Okay. So now condition is satisfied. Whatever inside mod doesn't matter. Doesn't matter. Getting? Whatever inside mod doesn't matter. But in the right hand side, we should have 1. So let us go further. So what is the f of z we have? F of z is minus 1 by z plus 1 upon z minus 1. So as I told you earlier, inside mod we have z, here also we have z, so I will not disturb it. I need to work on this part only. So minus 1 by z plus. But the problem is that if you want to use that series, the condition should satisfy. I am going to tell you one technique. The technique is whatever in denominator, we take that term common. What did I say? Whatever in denominator, I take that term common. So here in denominator we have z. So let us take z common. Let us see what will happen if I take z common. So if you take z common, we will have 1, and from 1, how can we take z common? So that's why I need to write 1 by z. If you multiply it again, you will have the same term. Okay. Let us go further. Okay. So for first part, we need to simply copy paste minus 1 by z plus, see, 1 by z into I am writing the same thing, 1 minus 1 by z. So this is equal to minus 1 by z plus 1 by z. So now there is one question in my mind, that is, can I use this expansion for this bracket? Let us see. See, in these expansions we have 1 first. So here also we have 1 first. We have minus sign, so we need to think about the second series. Here the term z having mod less than 1. Here the term 1 by z, is it mod less than 1? Yes, we have its mod less than 1. So definitely I can use that expansion. Let us see what will happen. Simply at a place of z, I have 1 by z. So in series also at a place of z, I need to write 1 by z. So 1 plus 1 by z plus 1 by z square plus 1 by z cube plus and so on. That's it. This is the required Laurent series. If you want, you can do it further. We can solve it further. So minus 1 by z if you want. Otherwise, this is completely okay. Let us multiply 1 by z plus 1 by, I am solving the bracket. So I need to multiply each term by 1 by z plus 1 by z cube and so on. See, this 1 by z minus 1 by z will get cancelled. 1 by z square plus 1 by z cube plus 1 by z is to 4 and so on. So this is required Laurent's expansion for a given function, right, for this region. Okay, so that's it. The second part is also over. Let us go for next. Just make a screenshot of it. So this is the third sub question we have, or you can say the given condition. 0 less than mod z minus 1 less than 1. Let us talk about the region first. So for simplicity, I am going to replace inequality by equality. So this is equation of circle, obviously. Its center is 1. 1, that means 1 comma 0. Real part is 1, imaginary part is not there, so that's why 0. Its radius, that means in right hand side 1. So let me draw a circle here. Whose center is 1, 0 and radius is 1. Okay, imaginary axis, real axis. So you know that at center 1 comma 0 will be somewhere here and the radius is 1. So let me draw the circle with center 0, 0 and radius 1. So this is my circle, try to understand. Okay, so strictly less than 1, so that's why I've shown it by dotted lines, and it's greater than 0. That means actually the center is removed. The center is actually removed. Okay, so such type of disk we have, and it is less than 1, that means interior part of this circle. So this is a region we have. This is a region of convergence, right? Okay, so let me remove this one. Let us go further. So I should think about the condition first. So we have, let me highlight the thing, that mod z minus 1 less than 1. Okay, mod z minus 1 less than 1. See, as you can see here, we want something less than 1. Fortunately, we have got the same something. It doesn't matter what we have here, but it is less than 1. That thing I have got. So let us go further. What is the function we have? F of z is equal to, let me mention, minus 1 upon z plus 1 upon z minus 1. You remember I told you the one thing, that is z minus whatever inside mod, that term we need to adjust. Inside mod we have z minus 1. Fortunately, we have got z minus 1 here. So I will not disturb this term. I need to work on the first part since there is no z minus 1. So let me simply copy this term here. I'm not going to disturb it. Sorry, z minus 1 we have now. And this thing I'm going to write here. So 1 upon z minus 1. So here also I need to bring z minus 1. So how to bring z minus 1? Simple technique. Z minus 1 plus 1. Minus 1 plus 1 will get cancelled. You will have z again, right? Okay. So in this way we manage z minus 1 there. Okay. So let us find the expansion. So 1 upon z minus 1. So now I am thinking about to use these expansions. But the problem is that always we have 1 first. Do we have 1 first? No. But we can manage it. No. Mod z minus 1 plus 1 is same as 1 plus z minus 1. So I am going to write 1 first. 1 plus z minus 1. Okay. So having a same meaning. So I could write it. So this is equal to 1 upon z minus 1. So now the question is, can I use this expansion? Let us see. 1 we have here, also we have 1, plus we have here. Here we have z, here we have z minus 1. That means at a place of z, we have z minus 1, otherwise there is no difference. Let us see the condition is satisfied or not. Here the condition is mod z less than 1. Let us see its mod is less than 1 or not. Yes, they are directly given to us. Its mod is less than 1. That means condition is also satisfied and I can use this series. So by this series I can write, see, this expansion I am going to use. At a place of z, simply we have z minus 1. So let us write 1 minus z minus 1 plus z minus 1 square minus z minus 1 cube plus z minus 1 raised to 4 and so on. So this is required Laurent's expansion. Okay, so the third sub question is also over. So let us go for the last sub question. Just make a screenshot of it. So the last sub question is 1 less than mod z minus 1. Let us talk about its geometry. I am going to replace inequality by equality. So 1 is equal to mod z minus 1. That means mod z minus 1 is equal to 1. So this is equation of circle. What is its center? 1. That means 1 comma 0. Real part is 1. Imaginary part is 0. Radius. So the radius is 1. You can see. Let me draw the diagram. Imaginary axis, real axis. Okay. Center 1 comma 0. It will be here 1 comma 0. And radius is 1. So let me draw circle. We had got the same circle last time, right? But see what is the difference? Here we have mod z minus 1 greater than 0. Mod greater than its radius. That means we have to consider the exterior part of this circle, okay? Or this disk you can say. So we have the region like this which lie on outside this, okay, circle. Okay, so this is the region we have. So let us talk about the Laurent's expansion now. So this is the region of convergence. So first we start with a given condition, that is 1 less than mod z minus 1. See, our final target is to use this expansion and we need to think about their conditions also. So in conditions it is mentioned mod less than 1. In the right hand side we want 1. Here in the right hand side we have mod. Actually we want 1 there. So for that what will I do? I will divide both sides by this mod. If you divide this side by this mod, you will have 1 upon z minus 1. And if you divide this side by this mod, you will have 1. So I got something less than 1. That means, okay, that type of condition I have, that type of condition. Okay, so let us go for then f of z. What is my f of z? Let me write minus 1 by z plus 1 upon z minus 1. So as I told you earlier, whatever inside mod z minus 1, yes, I have the same whatever the term inside mod I have got here. So I will not disturb this term. I will keep as it is. So it is 1 upon z minus 1. I need to work on the this 1 by z. Okay, so I have written this thing first, this thing later. Let us continue. So this is equal to 1 upon z minus 1. So here also I want the same term, since in a series we should manage this z minus 1 everywhere. What will I do? I need to adjust z minus 1 here. The simple thing I can do, that is z minus 1 plus 1. They will get cancelled, you will have 1 by z again. But see, that bracket is managed. I have managed that bracket. So let us talk about its expansion. I want to use this series. But see, here always we have 1 first. Here also we have 1. So let us simply interchange. So we will have 1 here. Okay, see, but see, we need to manage this, this condition also. Okay. You remember I told you one thing. Whatever we have in denominator, I should take it common. So in denominator I have z minus 1. So let us take it common. So minus, I am going to take z minus 1 common, z minus 1. If you take z minus 1 common, I will get here 1, and if I take, there is no z minus 1, so I should write this. If you multiply, again you will have the same thing, getting? So why I am doing it? Since I want to manage that condition which I got this one. So the technique is whatever in denominator, we should take it common. I have done the same thing. This is equal to 1 upon z minus 1 minus 1 upon z minus 1 into 1 upon 1 plus 1 upon z minus 1. Okay, so this thing I have. This is equal to 1 upon z minus 1 minus 1 upon z minus 1 into, let us talk about its expansion, 1 upon 1 plus 1 upon 1 plus, that means this series is applicable. Same pattern we have, right? At a place of z, we have one complicated term, that is 1 upon z minus 1. So here mod z less than 1, so its mod should be less than 1, then only we can expand. We have its mod less than 1, so definitely I can find the expansion. I am going to use the same series. At a place of z I have this term. So 1 minus 1 upon z minus 1 plus 1 upon z minus 1 square minus 1 upon z minus 1 cube plus and so on. So this is a required Laurent series. If you want, you can solve it further. Okay, let me show you here. Let me remove this diagram so I can work on it. If you keep as it is, no problem. That will be the Laurent's expansion. But see, we can work on it further. 1 upon z minus 1 minus, let us simply multiply, solve this bracket. This one into 1, you will have the same. If you multiply the second term by this one, minus minus plus 1 upon z minus 1 square. If you multiply the third term by this one, you will have minus 1 upon z minus 1 cube plus and so on. So first two terms will get cancelled and we will have 1 upon z minus 1 square minus 1 upon z minus 1 cube plus 1 upon z minus 1 raised to 4 and so on. So this is required Laurent's expansion, and you can easily see whatever inside mod we have got it everywhere. So this is required Laurent's expansion. So the example is over. Make a screenshot of it, then we will stop. Thank you. See you.